Hi everyone, so in this video we are talking about compound interest, which is a common application of exponential functions. To start off with, consider both of these options and let's see if we can make some money. Just imagine that you're going to either get $100,000 each day for 30 days and you'll add it all up at the end, or start with a penny and double it each day for 30 days. Which do you think you want? So I encourage you to pause the video and try it. See if you can figure out which option is better, which you should take. This is for real, I'm totally gonna give you this much money. So on option 2, it doesn't accumulate, it's just whatever you have on day 30 is what you get. On option 1, we're adding up 100,000 each time. So option 2 is actually the best. Here I have it all written out. Let's start with option 1 actually. Option 1, you just have 100,000 times 30 days, which is $3 million, which I would take $3 million. However, if you start with a penny and you double it, and double it again and again and again, it starts off kind of slow. So by day 10, you're only at $5. By day 20, you're at $5,000. And by day 30, you're at over $5 million. So you just barely passed option 1, and then it would continue to get crazier and crazy higher. A shortcut for this would be start with your penny, 0.01, and then do times 2 29 times, because from day 1 to day 2, you multiply by 2, and then times 2 again, and times 2 again. And so you've multiplied times 2 29 times to get to day 30, basically because we don't multiply day 1 by 2. And so there you have it. I'm going to give you $5 million. So a lot of exponential functions have to do with money situations. So let's talk about how to get rich or to not be in debt. By the way, if you're an actuary, which like you work at a bank with money, the starting salary these days is about $107,000. Or sorry, no, that was the average salary. So not a bad job. Might be important to know some of this stuff. Okay, so let's imagine you're going to put money into a bank account. It could be any amount, let's say maybe $1,000 into a bank account. And then that account accumulates interest. So interest means like you gain a certain percentage of whatever money you have. So like let's say the interest rate is 3%. As a decimal, you move the 2 spots, that would be 0.03 as a decimal. If I want to find how much interest I'm going to make off this $1,000, I just do 1,000 times 0.03, which would be, what is that, 30, 300? Move the decimal twice. Yeah, 30. Just wanted to make sure I was doubting myself for a second. It would be $30. So if I find 3% of this 1,000 here, it's $30. So that's not what's currently in my bank account. I didn't magically go from 1,000 to 30. This is the interest. We call it simple interest. This is what is going to get added on, usually each year, to my bank account. So now after I calculate the interest, I'm now up to $1,030. When I calculate the interest again, it's no longer going to be $30 because 3% of this is not 30. If I do this times 0.03, let's see what we get. I get 30.9, so $30.90. It's almost 30, but it's a little bigger. And so now I'll add this on to the original amount, and you keep that process going. That process of calculating the interest and adding it on is called compounding because it compounds like on top of each other. So a shortcut for this would be basically you want to take the money in your account, say $1,000, and if I wanted to jump straight to like how much money am I actually going to have in my account after I add on the interest, you would do 100% of the 1,000 plus an additional which as a decimal would be 1.03. Because this is taking 100% plus an additional 3%, which is 1.03 as a decimal. So this is just kind of a shortcut you can use. Keep that in mind. There's a formula that will do all of this for you, and it's called the compound interest formula. It's on your formula sheet on the left side of the exponential stuff. You could also just Google it if you needed to look it up in the future. There's a lot of pieces here, but it's basically what we just did. A stands for the amount, the new amount in your account or the debt that you owe, anything like that. And then P stands for the principal amount. Principal means the original, like the $1,000 that you first put into your account. And then we multiply it basically by 1 plus the rate. This is like we just talked about. You're going to have to do 100% of the original plus the additional interest rate that you gain. The rate does need to be a decimal, so just be careful with that. And then you do it to the t power, t being time, usually in years, that the money has been in the account or invested or borrowed or whatever time you're talking about. The only thing we haven't mentioned is this n. And the n you don't always need. However, the n is the number of times per year that the interest is compounded. So like, remember compounding is like when you calculate the interest and you add it on. If it's compounded like monthly, so 12 times a year, you would put in a 12 for n. If it's compounded semi-annually, like twice a year, you would put in a 2 for both of those n's. Let's see this in action. So imagine, let me see here. Okay, imagine you deposit $4,500, so that's your principal amount, at 5% annual interest. So that's your interest rate. We do want to convert that to a decimal, so move the decimal twice, that'd be 0.05. It says it's compounded quarterly. There are 4 quarters in a dollar, 4 quarters in a year. This means our n value is 4. So how much money will be in the account after 10 years? That's our time, t. Just literally just plug it all in the formula. Start with the principal amount, 4,500, times 1 plus the rate, so 1 plus 0.05, but I need to divide it by 4 because it's compounded quarterly. And then I'll do to the 4th power times 10, which is time. Type all that into your calculator. You may just want to make that a 40. And so 4,500 times 1 plus 0.05 divided by 4 to the 40th power, and you get 7,396.29. I'm going to round to the nearest cent. So pretty handy formula. It can tell you how much is in your account if you're accumulating a certain percentage of interest. This also works with debt, right? Like imagine you start with this much debt and then your debt continues to accumulate with interest, and then this would be how much you owe if you hadn't paid any off. And so it's a bad thing if we're talking about debt. It's a great thing when we're talking about money in your account. By the way, the interest rate is important, right? This is what people talk about when they buy a house or get a loan. You want if you're going into debt, you want a low interest rate so that you don't have to pay that much money. If you're saving money, you want a high interest rate so that you accumulate more money. And you can see the longer that it's in the account, the more money you're going to have. This is why people say to invest early, because it's exponential. It's going to grow more and more rapidly as you get older. As it's been in the account longer, it's going to get more and more growth. And so this is why you want to invest money in your retirement as soon as you can. Let's try one more problem. Okay. So this time our principal is $4,000. The interest rate is very high, it's 9%, which is 0.09. That's our rate. it's compounded monthly, so 12 times a year. How long until there is 10,000 in the account? So I don't actually know t, I want the amount to be 10,000. So let's fill in everything we have. Our principal is 4,000 times 1 plus the rate divided by n, which is 12, and then 12 times t, but I don't know t yet. I do know that I want all of this to equal 10,000. You have a few different options to figure this out. One way is to use something we haven't talked about yet called a logarithm to solve this. But you could honestly just kind of guess and check some values for t and see which of those will give you 10,000. Or you could put this in your calculator in y equals and then go look at the table and see when you get to 10,000. That's what I'm going to do. So I'm going to go 4,000 times 1 plus 0.09 divided by 12 to the 12x power. And then when I go look at the table, I don't get to 10,000 until it's right in between 10 and 11 years. So when t is 10, we're currently at $9,805, and when t is 11, we get to 10,725. So it would be the 11th year that you finally have over $10,000 in the account. All right, so that's compound interest. One thing I did want to point out is when t is 0, that would be like after 0 time has passed. Let's see what happens. N times 0 would just be 0, and then all of this to the 0 power would be 1, because anything to the 0 power is 1. And 1 times the principal amount would just be the principal amount. So when time is 0, you just get the principal, which is what we would expect. After 0 time, you still just have the principal amount.